Alright, Mr. Trutna here. We're going to go over Unit 9, Worksheet 1, and we're going to go over numbers. We're going to start at number 7, and then we're going to work our way all the way through number 27. Alright, so in numbers 7 through 17, what we're going to be doing is we're going to be simplifying each expression. Okay, and we're going to be simplifying each expression by either addition or subtraction. Okay, so in number 7, excuse me, we have 5x plus 5x. So remember, when you are adding, we're always looking at like terms. In order for terms to be alike, they have to have the same exact variable, x, and the variables have to have the same coefficient. If that's the case, what you do is you add or subtract the coefficients. So you're going to go 5 plus 5, that is 10, and then you leave the variables and you leave any coefficients as is. So number 7, 10x. Okay, in number 8 we have 7y minus 3y. So once again, whenever we're adding or whenever we're subtracting, we're always thinking like terms. These terms are like because they have the same exact variable, and each variable has the same coefficient. So what we do in this case, we're going to subtract the coefficients, 7 minus 3, 4, and then we leave the variable and any exponents as is for addition and subtraction. Number 8 would be 4y. Okay? Number 9, notice we're taking 7x squared, we're adding it to 7x squared. They both have an x in them, so the variables are the same. The variables have the exact same exponents, so we can add these together. So we take the coefficients, we add them up, 7 plus 7, that is 14. Then we leave the variable as is, and we leave the exponents as is. Number 9, 14x squared. Okay, same idea with number 10. We're going to take the coefficients, which is a 4, and then this coefficient we have to treat as a negative 12, so 4 minus 12 is negative 8. And then we leave the variable x as is, we leave the coefficient or the exponents 3 as is. So number 10, negative 8x to the third. Okay, number 11, when you're adding and you're adding grouping pairs, i.e. parentheses, the first thing that you have to do is you have to rewrite the problem without the parentheses. So how do you do that? Well, you take the number in front of the parentheses, and if there's no number there, it's implied that it's a 1, and you distribute. So I'm going to go 1 times 7x, that's 7x. Then I'm going to go 1 times positive 9, that's positive 9. That eliminates the parentheses. I'm going to do the same thing over here. Take that implied 1 and distribute the positive 1. Positive 1 times 3x is positive 3x. Positive 1 times negative 5 is negative 5. Now, once I do that, now I'm looking to combine like terms. So I can combine the 7x together with the positive 3x. So I add the coefficient, 7 plus 3 is 10, and then I leave the variable x as is. Okay? And then I could do the same with the constant numbers, positive 9 minus 5. Positive 9 minus 5 is positive 4, so this is my answer here to number 11. Okay, now I cannot add 4 to 10x, so that's why I'm stopping right there. That is, it said, the instruction said simplify, so I'm simplifying. Number 12, same idea. Got to rewrite the problem without parentheses first and foremost, so I'm going to distribute the 1 into the first parentheses. That's going to give me 4x minus 7. And now when I get over here, when I distribute this, I'm distributing a negative 1. So negative 1 times x gives me negative 1x. Negative 1 times positive 2 gives me a negative 2. Now I look to combine like terms. That 4x is like with the minus 1x because they have the exact same variable. So I take the coefficients, 4 minus 1, subtract, that's 3, leave the variables as is, 3x. Then I take the constant numbers, that's the numbers without any variables, which is a negative 7. I combine it with a minus 2, that gives me minus 9. Okay, now, can you subtract 9 from 3x? The answer is no. Therefore, number 12 is simplified. Okay? Number 13, I have grouping symbols, so you always want to rewrite your problem without grouping symbols, the first thing you do. So I have an implied 1 here, so I'm going to distribute. 1 times 10x is 10x. 1 times positive 3y is positive 3y. When I go over here to the next grouping symbol, this is a negative 1 here. I'm going to distribute the negative 1. Negative 1 times 2x is negative 2x. Negative 1 times positive 9y is negative 9y. Now once I get to that point, now I'm looking to combine like terms. 10x is a like term with a minus 2x, so I take the coefficients, 10 minus 2, that's 8, and I leave the variables as is. Then I have a positive 3y, that's like with the minus 9y, so I take the coefficients, positive 3 minus 9, that is negative 6, and then I leave the variables alone. Okay, now you cannot subtract 6y from 8x, so that would be your simplified answer to number 13. Okay, number 14. Once again, we have grouping symbols, so the first thing we need to do is we need to rewrite the problem without grouping symbols. So I'm going to distribute a 1. 1 times x is 1x. 1 times positive 7y is positive 7y. Going to the next grouping symbol, I have a positive 1 that I'm going to distribute, times 2x is positive 2x. Positive 1 multiplied by it, and we have to treat this as a negative 12y, would give me negative 12y. After we get rid of the grouping symbols, i.e. the parentheses, I'm looking for like terms. So you can see these two terms are like, so I can add them up. Take the coefficients, 1 plus 2, that gives me 3, leave the variable alone, x. The next set of like terms, I'm going to take the positive 7y, it's like with the negative 12y, so take the coefficients, positive 7 minus 12 is negative 5, leave the variables alone. Now you cannot subtract 5y from 3x, therefore that's your simplified version for number 14. Okay, number 15, we have a few more terms involved in the problem, but we're going to attack it the same way. So I have grouping symbols, so the first thing I do is I want to get rid of the grouping symbols. Take the implied number in front of the grouping symbol and distribute. 1 times 3x squared, 3x squared. 1 multiplied by positive 7x, positive 7x. 1 multiplied by negative 8, negative 8. Then I'm going to go to the other grouping symbol, the next grouping symbol, and I'm going to distribute a positive 1 times a 5x squared, that's positive 5x squared. Positive 1 times negative 4x is negative 4x. Positive 1 times positive 8 is positive 8. Okay, once I get to this point, now when I get rid of the grouping symbols, I am going to combine like terms. Now, in order for things or terms to be like, they have to have the same variable, okay, and then the variable has to have the exact same exponent. So 3x squared is like with 5x squared, but don't think and don't make the mistake of thinking that 3x squared is like with positive 7x because they both have an x. These two are not like because that x does not have the same exact exponent. So I can combine these two. Take the coefficients, 3 and 8, add them up, 3 and 5, excuse me, that's 8, and then we leave the variable alone, x, and we leave the exponents alone, a 2. Okay, now I'm going to go to my next term, which is a positive 7x. You could see it's like with the minus 4x, so I can combine those. Positive 7 minus 4, the coefficients, that gives me positive 3, and then I leave the variable alone as x. Okay, last one, now I take the constant terms. Once again, the constant terms are anything without a variable, and I have a negative 8, I add it to an 8, well those would cancel each other out, so this is my solution, simplified solution to number 15. It's not really a solution, it's just my simplified expression. Okay, number 16, I have grouping symbols, so I'm going to rewrite the problem without grouping symbols. Distribute a positive 1. Some of you guys have figured out that when you distribute a positive 1, it does not ever change any of the expression inside the grouping symbols. So I really don't have to do much thinking here. But now when I get to my second set of parentheses, my second grouping symbols, I have to distribute a -1. So -1 times positive 6y to the third is negative 6y to the third. -1 times positive 4 is -4. -1 times negative 6y squared would be positive 6y squared. Okay, after we eliminate the parentheses or the grouping symbols, then we're combining like terms. So I'm looking for other y to the thirds. You could see I have a minus 6y to the third here. Okay, so I can combine those together. I take the coefficients, which is a 1, minus the 6, that gives me -5. I leave the y, I leave the exponent, the 3, as is. Okay, then I'm going to go to my next term, my -4y squared. I'm looking for y squareds. You can see I have one here at the end. So I'm going to combine those. Take the -4, add it to 6. That gives me +2. Leave the y, leave the exponent of 2 as is. Then I'm going to go to my last terms, which are my constants. I have a -2. I have a -4. I combine those. That makes -6. Okay, so now we think to ourselves, am I done? Well, can I add 2y to the seconds to -5y to the thirds? The answer is no. Can I subtract 6 from 2y to the seconds? The answer is no. So I can't do anything more, so there's my simplified expression. Last one of the addition, number 17. So now I'm going to once again distribute to get rid of the parentheses, the grouping symbols. If you just distribute a +1, you really don't have to do any thinking. That just eliminates all it really does is it eliminates the parentheses. The second set of parentheses, though, I have a -1 that I'm going to distribute. -1 times -5r squared is +5r squared. -1 multiplied by +r will give me a -r, and -1 multiplied by a +8 would give me -8. So after we do all of our distributing, then we look to combine like terms to simplify. So I'm going to start with the r to the thirds. I have a -9r thirds. You can see there are no other r to the thirds, therefore there's nothing to combine, so my simplified expression is going to have a -r to the thirds. Then I'm going to work down in descending order by exponent. So the next thing we're going to look for is r to the seconds, or r squareds. I have no other r squareds, so that means I'm going to have a +5r squared in my simplified expression. Then I go to the r's. I have a +2r. That's alike with the -r. That's like a -1r. So +2 minus 1 would be +1. So I get +1, and I leave the r as is. So that's just +r, which is like a +1r. Then I'm going to go to the constant terms, which is -1 and -8. I combine those together, and I get -9. And there's my simplified expression to number 17. All right? So that's how you would go about doing numbers 7 through 17, which is involving addition.